Hi, I'm Taylor Carpenter with Vulk Coop. Here with some of my colleagues, including Denver Williams. He's out here. He's going to help with some of the QA at the end of this. We're going to be talking about CI for network functions in the NFV world. This is from using the CrossCloud CI, one of the CrossCloud CI components, a CNCF project. So CrossCloud CI test different versions of Kubernetes and then projects that run on those clusters across multiple cloud providers. And the CNF project is providing reference code and test comparisons for cloud-native network functions. We'll talk a little bit about both projects, intros for those, some lessons learned, and then what's next. And we'd love to get folks to collaborate, and then a Q&A at the end for any questions. So the CrossCloud CI project, it consists of a base CI system that has several parts, and then a status repository with an API, and then a dashboard to display the status of those results. The CI system has a build pipeline, a cloud provisioning portion, and then a app deployment pipeline. On this project, we actually validate different versions of the software daily. So the goal on that project has been to target CNCF projects for deployments, as well as non-CNCF, and then targeting, hopefully, as many of the cloud providers and bare metal and private clouds. By October of 2018, we have 8 cloud providers that are supported on the platform that we can deploy to. So the CNCF CI is an instance of the CrossCloud CI project that has the dashboard showing, and it's refreshed at 3 a.m. Eastern daily to show all the projects that are currently active and wanting to be tested, as well as those cloud providers. It looks a little like this on a good day. If you look at it today, you're going to see some different statuses, but I'm not going to get into all those details right now. It'll show failures. It'll show if it needs to skip. You can click through the different buttons. You have that build pipeline, Kubernetes provisioning pipeline, that's CrossCloud, where we're going to be focusing today, and then Cross Project, which does the app deployments. And then all of these can run different tests, including integration end-to-end test, whatever we have to work with from the project. So on that Kubernetes provisioning, we can build and use different Kubernetes artifacts and releases, take those and deploy them to different cloud providers, and then we can run the test, like say conformance test if we would like, or different flags for the providers, and then update the dashboard. So this is showing those releases on the dashboards for CNCF CI. We're doing the stable and head of master, and then we provision the clouds with those releases. So these are all individual clusters, and then we use Helm to deploy the apps to all of those clusters. So a quick overview of the whole system. Right now, underneath, we use GitLab to run different jobs of the software, like actually running the cross-cloud components and then pulling back information. Helm for both app deployments and running EDE tests, which we usually put in containers. And the CrossCloud itself is a mixture of Terraform, which allows us to target multiple cloud providers easily. There's usually the provider code is maintained by the clouds, and then Cloud Init is normally used to kick off the bootstrapping of Kubernetes with per cloud manifest and configuration. And then all of this is driven from Git and YAML configuration. So the CNF project. Well, similar to data center, when everyone's trying to move towards, moving towards the cloud-centric type of methodologies, there's a move in the NFV world to do that. And this project is creating reference code and test comparisons and helping with collaboration. Using the CrossCloud CI was a part of that, another project. Ideally, someone can take the code from the CNF project, reproduce the entire environment, the whole test bed on a supported provider, and do that with an API key and running a few commands. So how do we get to CI for NFV testing? We look at creating a neutral test environment. So by that, we're saying commodity hardware, ideally, for this base testing, looking at public clouds and open environments. So Linux Foundation has the FDIO project and a CSIT lab, and then Packet has bare metal. And then we look at software. Everything's 100% open source for us. The NFV world, you're going to have both, but we're looking at how do we get people to collaborate on these type of open testing. Vanilla Kubernetes for what we're looking at today. That's going to be across the board when we're doing comparisons like OpenStack or KVM using Helm, and then trying to work with different groups. Kubernetes Network Service Mesh, the FDIO project for VPP software and other things. Once we have that kind of as our target, how do we make reproducible infrastructure? So servers, switches, setting up all the networking and connection. On the servers themselves, this is an example of Packet, so a lot of content here. This would be one of the machines, this M2 extra large. It's a Dell, happens to be a Dell with them. We can configure all this or provision it initially with Terraform. So that gets us part of the way. We can deploy a cluster with different numbers of compute nodes, worker nodes, and master, whatever we want. So this works kind of out of the box with CrossCloud. We can decide on size of the resources and those sort of things. But what about layer 2 networking? So this isn't something that's currently supported in Kubernetes, but there's a lot of effort to move towards that. We need to do the wiring. We have all the host configuration that you have to handle. Then we want to connect the different network functions in different topologies. So how do we do that? Well, we extended CrossCloud to support different things that we need right now and try to keep this pluggable. So right now, this means adding the support for an Ansible Terraform plugin so that we can use roles and other things that we're using for OpenStack and KVM. We can pull down stuff from other groups. We added support for CPU management policies and some other specific Kubernetes things so that we can isolate the hardware usage, which is really important for performance in this side. And then all services that we're running for this are bare metal, important specifically for network function testing. And then we're connecting the layer 2 network with VPP. So this is an open source software it's a stack that you can configure to do what you would do with maybe a Juniper switch or Cisco or whatever you want. It'll handle a lot of different configurations, and it does very high-speed networking. So we use this at the host layer for what's called a vSwitch, and then within the containers themselves, we're also using VPP, but that would be a separate thing. The main thing here is the host switch. So normally with Kubernetes, you're going to let Linux kernel handle all of the connections. So for this, we have to decide maybe the public internet pieces are going to be handled by Kubernetes, just as you would have it. And then the extra interfaces that we add to the containers we hand off to VPP, and that lets us get that high speed. And this is where the Ansible and other pieces kind of tie in. And right now, that's configured kind of outside, so it's in collaboration with, we configure Kubernetes, and then we build out the host networking, and they kind of meet. There's other projects like Network Service Mesh that are hoping to provide those as services. So we've made this pluggable so that we can add those in later. The other part here that I'm showing is the connecting. How do you connect these? We're not using the normal networking. We're using high-speed MIMIF sockets. So here's some of the features that we've added to CrossCloud. It was using CoreOS as the base host OS. Now we have support for CoreOS and Ubuntu. We can use reserved instances at Packet. So it was doing on-demand for everything, AWS, wherever. So for Packet, you can use both the on-demand as well as reserved instances, which may be configured differently. With a reserved instance, you can go into the BIOS and do additional items. The CPU management policies and other things for isolation of the hardware. And then a few other items on rebooting. So we update like grub configuration and other host configuration. So you want to be able to reboot those nodes once you've made changes to the default OS that's handed by the provider. In this instance, Packet. So lessons learned. There's some general challenges with moving from virtualized network functions that are running in VMs to the cloud-native equivalents. Reproducible infrastructure, so that's before we put maybe the platform, Kubernetes, OpenStack, and then the actual clusters. How do we make those work? So here's a lot of content. This is actually from Dan Kahn, talking about the move from physical hardware to virtualized. You have the ability to use custom kernels, custom drivers in the virtual machines, and you can do a lot of other things there to make sure it works and you get that high performance. When you move to containers, you don't have the same abilities. You're using the same kernel as the host and other things. So how do you deal with that? The layer 2 networking. With virtual machines, you can create whatever interfaces you want. This is different there. So there's those sort of challenges. On the infrastructure, we've seen a lot of different things. This is probably stuff you're going to see on any provider. So the APIs. So there's things that we ran into pretty quickly where maybe on Packet, they have it in an API, but they don't support it in the libraries, because these aren't things that other people are doing. So we're kind of driving those early access to configuration of, say, the switches. And we may be able to update something on the API, but we can't actually go retrieve something in a list. So we have to go somewhere else in the API to pull something, and somewhere else, put it all together and come up with what we wanted. And so that's one of the things that we ran into pretty quick. The switch configuration. So what am I talking about here for it doesn't work as expected? So for that layer 2 configuration, any of the physical switches are likely to be able to set up the layer 2 configuration that people want if you have direct access. We have an API that's external to that and trying to limit problems. So some of the things that you would expect to be able to do on the switch may not work as expected. You start having limits on what you can do. So that means your configuration and setup of the cluster and the machines is going to be different than expected. And then if you're going to compare to another environment, say Packet to the FDIC CSIT lab, now you may say, well, we need to set that up. Can it be set up the same? So those sort of things. Limits within the provider to make sure resource utilization is kept to a point where all the customers get what they expect. So we've run into stuff like the amount of VLANs that you can create, so those virtual networks for layer 2. Within a project, maybe the facility doesn't have as many of a type of device, those sort of things. So those further limit how the clusters and everything that you're going to set up. It doesn't stop, you just have to start being creative or decide that maybe you're going to do a different use case. The clusters themselves, so OpenStack, from the OpenStack side, we really want, similar to Kubernetes, so this is for comparison, Kubernetes, KVM, anything we're looking at, we'd like for other people to be able to reproduce and provide feedback on, is this something that would be standard within the context of what we're using? Is this best practices? So we're wanting that reproducible. And we found it's difficult to have something that's more general purpose for an OpenStack clusters. And we've started with many different paths for this, including using code and deployments from other projects. We've provided a lot of updates on those. Nothing was quite getting us to bare metal, something that we could say uses HA controllers and compute nodes that are going to be comparable to a Kubernetes cluster. And so that's been very difficult. We've pushed through, and in the last couple of months, we've got to a point where we have reproducible OpenStack that's not yet high performance. And that's where this next part comes in, the host OS. So we can have a lot of it working if, say, you're on CentOS, but then maybe something else doesn't work with packages. So then you are looking at Ubuntu or whatever on those. What are the pieces that we need for this? So dealing with those dependencies has been, and that's across the board, not just OpenStack. The standard plugins, this ties in with the high performance. One of the things that we're trying to do is make sure to use the same software where possible unless there's a standard already in that community. So I was showing earlier VPP for that high performance networking. You can use VPP in OpenStack and KVM and other places. For OpenStack, they have a VPP Neutron plugin. And you would ideally use that for your configuration. So it's going to be similar. It's going to be the standard. It's how you would set up Neutron. Unfortunately, the software versions that we need for supporting, say, drivers on a particular machine on Packet, they don't match the built-in packages that you would use for the VPP with VPP Neutron and stuff, at which point you have to make the call that we're going to do source builds and kind of go down that path. It's not a blocker where you can't do it. It's more of where are we going to go off of those standard tracks, and then we have to make sure and have very good documentation on why we did it and the steps for reproducibility. So what's next? We're working with a lot of different groups, network service mesh. We have pull requests from different folks for trying to make updates. This is back to CrossCloud. So the provisioner itself, the Kubernetes provisioner. We have different enhancements, requests, and updates from different folks. We're trying to gather more feedback from everyone on this, as well as the CrossCloud CI project as a whole, which has other components. We have some features that we kind of know we want to add support for. So network service mesh, this is what's supposed to help with a lot of the layer 2 configuration for Kubernetes. So we're working closely with them and helping to drive some of the features and test. So that's one of the pieces where we think we're going to be adding support for. Looking at adding layer 2 configuration support with other providers. So outside of Kubernetes, you have the infrastructure. We care about reproducible there. So we'll be looking at other providers like what does it look like on AWS, bare metal? We don't know yet. Hardware-wise, okay, but what about the network? kubeADM. We don't use kubeADM to bootstrap Kubernetes right now, but we're looking at having that at least as an option once the resources are allocated, and some other items. So we'll be talking about CNFs more at a BOF later this afternoon. We're going to be at or helping with Mobile World Congress in Barcelona and ONS. And this is kind of related to both projects. I'm going to kind of jump through here on the CNFs, what we're going to do, and how to collaborate. So there's a CI Working Group. There's a lot of different projects that are coming on there, including Open Labs. CrossCloud CI would be one of the topics. Here's a GitHub for the CrossCloud Provisioner. So this is the Kubernetes Provisioner. If you're interested in the CrossCloud CI project in general, there's a lot of other components. You can connect with us on GitHub, Twitter, and there's a CNCF CI Slack channel. This is on the Cloud Native Slack. You can reach us there about this or the CNF channel about that project. With that, does anyone have any questions?
This is on? There it is. The CNCF CI Dashboard, the red greens, does that reflect successful testing of each component on the cluster, or just deployment of each component on the cluster?
Right now, it's kind of a high level of something, it all passed is green,
right? Or
something failed.
So
and then
that includes end-to-end tests then?
It can include end-to-end tests. So if for a project, for instance, that could be running an integration test. And for Kubernetes, it could be we're running the conformance test. It could be any of those. And then when you see a failure, so if you're actually on the dashboard, you can click through. So I could go and look at, this is for a build. It's going to bring you here. And we could try to look. So this is actually a build failure for some reason with Prometheus. And the success are going to be a little bit easier. I think Packet reached out to us this morning talking about a failure.
Do you have end-to-end tests for each component? The reason I asked, I've been looking at the source code the last month or two for my own specific use case, right? And
yeah.
it was hard for me to see beyond, so there's a cross-cloud and cross-project, and then there's the GitLab files for running the end-to-end tests. As far as I could tell, and maybe I haven't Git pulled recently, it basically would install the Helm chart for the component that you're testing, so Envoy, Prometheus, whatever.
Yeah.
And then it looked like it would, in order to test whether it's successful or not, basically some sort of while loop that checks whether pods are successfully started and things like that. Are there other end-to-end tests that I just didn't see in that flow that you're executing? So actual end-to-end tests as opposed to just checking whether something installs correctly or not?
So for instance, the Kubernetes or the Envoy or something else?
Yeah, for each one of the components, I would imagine each one of them would have end-to-end tests specific to their component, right? Or is that not the case?
That's the ideal. So Core DNS is a project they've been trying to figure out what type of integration test would be good for those. This is tying in with the collaboration, kind of how we want to work going forward. Talked about this in the intro yesterday. So we're planning a kind of a big rework and iteration for going next year, where we would like to have more projects maintaining a lot of this. And that's been a goal. So we're looking at how do we make that entry for them to do that. So ideally, Core DNS, who know that project, can provide their own integration test, and then those are running. We can make things up, but that's not going to ever be as good as in-user test.
So if I was to understand the code correctly then, because I think I saw only really end-to-end tests for the ONAP integration then, like it runs a container.
Yeah.
Which also, by the way, requires private credentials, which I'm not sure where to get from. I'll ask that as a
Yeah.
separate question. But all the other ones were just, you're basically, that's an ideal that you're waiting for contributions to run those integration tests.
Yeah, we've run some in the past, and there's been kind of some confusion on what does this do. Core DNS would probably be an easier one, because you could, there's a lot of ways to test DNS, whether it's Core DNS or any project. As you start looking at the other projects, it gets a little bit hairier. One of the goals that we have next year is doing integration between the projects, so not just end-to-end test on components. We've been hearing a lot of feedback on how would you use those projects. So then you may say Prometheus, Core DNS, there's a Postgres database and some other piece, and you have all those running, and then run a full integration test between those, which would be a lot more interesting. And as part of that, the dashboard itself that we were looking at will end up getting reworked. So there's going to be screens that are more of a focus on projects. And then we could say, here's the different integration test and stuff that's running. As far as the end-to-end test on specific components, we'd love to have those contributions as well. And we can turn those on pretty easy, like right now, if we had any.
Okay, thanks.
Mm-hmm.
So something that I've been looking at with respect to testing, or more Kubernetes broadly, that would be related to the talk. It was very informative, thank you. Have you looked at integrating OVN into CrossCloud at all, especially seeing that there's this new focus on network functions and networking as an area? OVN seems to be, NSX is in part based on OVS, and OVN's the open implementation of it, and there's really no deployment right now that uses it. And I've been looking at integrating it into some of my deployment tools, and I'm just wondering, because of this new focus on networking, if that's something that you're exploring as well.
From Kubernetes deployments itself, clusters for cross-cloud and stuff, we're definitely interested in testing different configurations, similar to different CNI plugins and all that. For the CNF project, so the network functions themselves, there's going to be a lot of different contrasting comparisons that we're going to do. We have OVS for the OpenStack, but that's more of the functional testing. So if you look at the ONAP project, one of their use cases, called a CP use case, has a lot of different components, and you could use OVS. You could probably compare that to OVN. Right now, we've been focused on high performance, the data plane network functions, and those are different. So you can't use something like OpenStack's OVS and get the type of performance. They're not in the same category.
Isn't OVN, please correct me, I think I'm probably wrong here, but I thought OVN was an implementation of the idea of OVS. And maybe OpenStack also has a project called OVS, which is an implementation of OVS, but I thought OVN was, implementing the idea of the open virtual switch, and it could be deployed on any Linux system that supports IPVS. Am I confusing acronyms at this point?
No, I'm not saying that
you said you mentioned contrasting OVN to OVS, and that's
no. I'm sorry. I was talking about with regard to if we're looking at we're mainly looking at as platforms and then potentially plugins, and for the telco world, there's one of the biggest focuses on performance.
Gotcha.
So we're pretty limited on what can be the vSwitch unless you go to non-open source solutions.
I understand. There was a talk the other day about even foregoing CNI altogether and just using real IP addressing for purposes of performance.
Yeah.
So, okay,
So
that
there-
makes sense.
yeah.
Thank you.
Mhm. Anyone else? Thanks.